All right, welcome back, everybody. This is section 3-4, day 2. Here's the warm-up. If you're watching along at home, go ahead and pause, do the warm-up, and then continue on whenever you're ready. So I would love to first go over at least one of them from 1 through 7. Somebody give me one to go over from 1 through 7, because a lot of people are like, I don't know how to do this. And in my mind, this is easier, but it just takes a little bit of time, no? Number 7. Let's go over number 7. So for number 7, I've got to find v of -2, v of 0, and v of 5, which basically means I'm going to plug in -2, which I have 12 minus 2 times -2 minus 5.8, which gets me 12 minus 2 times -2 minus 5.8. So 10.2. Then I'm going to do the same thing with v of 0. See, that's one of my answers. I'm going to do v of 0, which is 12 minus 2 times 0 minus 5.8. So that means I've got 12 minus 2 parentheses 0 minus 5.8, which gets me 6.2. So v of 0 is 6.2. And then lastly, I'm going to do v of 5. So 12 minus 2 times 5 minus 5.8. See, all I'm doing is just plugging in values and running numbers. It's not difficult. It just takes a little bit of time. 12 minus 2 times 5 minus 5.8. I sometimes feel like you guys are a little impatient rather than it being difficult. There we go. That's what's good. -3.8. So v of 5 is -3.8. Yes, sir.
So that's all you do is just plug in the number for the value on the
right
side?
Yeah, that's all you do. So it tells you to use -2, 0, and 5. So all you do is plug in -2, get your answer. Plug in 0, get your answer. Plug in 5, get your answer. I had somebody last period, like at this point, like trying to divide over the -2 because they thought this was like a multiply. Remember that that's not a multiply. That's just a notation. That's just how we read. We're saying, okay, this is the value of function v, the name, the value of function v at -2. So x value -2, input -2 gives me output 10.2. Input 0 gives me out 6.2. Input 5 gives me output -3.8.
And that's like the type of questions that'll be on our test on Thursday, right?
Yeah.
Okay.
Yeah. Okay, let's talk about, yes.
9.
I was just gonna say, let's talk about number 9 real quick. Let's talk about taking the notation and interpreting the notation.
Wait, are we testing on domain names?
Yep. You'll get your practice quiz with everything that's going to be on it. Let's see if TV, the number of customers in a restaurant, T hours after 8 a.m. So this is kind of like the problem we did yesterday where the input is time, and it's a time after a certain number, like it's time after 8 a.m. But our output is not temperature like it was yesterday. Our output is number of customers. So it's number of customers at given times after 8. So now, on the quiz on Thursday, this is another one where like you're going to have to explain your answer, use in words, be particular. So C of 0 is 0. What does that mean? C of 0 is 0. No?
Number of customers in the restaurant is 0 at hour 0.
Good. Number of customers is 0 at time 0. Or in other words, we could say the number of customers is 0 at 8 a.m. Okay, what does part B say then? The number of customers after 3 hours is the same as the number of customers after 8 hours. Okay, let's reword that. The number of customers at 11 a.m. is the same as the number of customers at, so 4 p.m. Right? The number of customers at 11 a.m. is the same as the number of customers at 4 p.m. Here, what is part C? Now, I don't love the notation for part C. I would say I like the one that's more numerical. We could say this though. The number of customers is 29 at time n. I don't love that. I want it to be a little bit more applicable. But the number of customers is 29 at time n. And we don't know what time n is. Yeah, we can just say time n. Yeah.
I said at some point there were 29.
Oh, that's good. That's a good way to word it. I like that. At some point, there were 29 customers. Good. Yeah, I like that. And then here, the number of customers at time 13.5. Okay, what's 13.5? So that's 21.5 altogether. So 9 and 0.5. So 9:30 p.m. 9:30 p.m. The number of customers at 9:30 p.m. is less than the number of customers after 12 hours. So 12 plus 8 is 20. So 8 p.m. Yeah, that's 8 p.m. 12 hours later. The number of customers at 9:30 p.m. is less than the number of customers at 8 p.m. Okay. Lastly, hopefully we were good with 11, 13, and 15. Number 17. I purposefully did not give you a problem yesterday in the notes like number 17 because I wanted to see how you did. Remember that what the notation is saying. The notation is saying if f of x is 7. Now, what does f of x mean? What's another way to say f of x? F of x really means what in any equation?
F times X? F equals?
Y. F of x means y, right? F of x and y are synonyms. However, if you call something f of x, you call it a function, and there's certain qualifications to that, right? We talked about that at length yesterday. So I'm saying when the y value is 7, what's the x value? Basically like this. On the line, what is the coordinate that has this coordinate? That's really what I'm asking you. What's the x value that has this coordinate? Well, let's look along the line. Here's 7 for my y value. Oh, it hits right there. What x value gives us a y value of 7? 5. So 5 is my answer. Oh, that's yellow. Okay. 5 is my answer. Because you're essentially doing the same things for 11, 13, and 15 as well. You're just solving them as an equation rather than solving them with a graph. Okay, let's go through the warm-up. Find the values of the function when x is -3, 0, and 2. All right, so that means I'm going to find r of -3, which is -3 minus 7. We plug that in our calculator. -3 minus 7, which is -4. So r of -3 is -4. And then we find r of 0, which is kind of easy to plug in. It'd be -0 minus 7, but -0 doesn't make sense. 0 minus 7 is -7. So r of 0 is -7. And then we say r of 2, which is -2 minus 7, or -9. Any questions on those three? Again, this should be a simple process, just kind of time consuming. Yes?
For the first one, there's 2 negatives.
Yeah, those 2 negatives will cancel out with positive. Yeah, so -3 turns just +3. +3 minus 7 will be -4. Okay, let's find number 2 here. Number 2. K of x is equal to 6x minus 12, and k of x is 15. Let's solve that one. Well, if my function is 6x minus 12, my output is 6x minus 12, and I want to know when the output is equal to 15. Well, I can just say this: 6x minus 12 is equal to 15, and then solve for x. Solve for that input. Add the 12 over to the other side, which gives us 6x is equal to 27. And I divide by 6, and I get 27 divided by 6. 4.5? Yeah, 4.5. And that's just my answer. Again, I'm looking for the input that makes that output equal to that 15, right? So just set that 6x minus 12 equal to 15. Yeah.
Wouldn't you write kx equals 4?
No. K of x means that's the output value.
Oh.
K of x is synonymous to y.
Okay.
And I'm looking for the x, not the y.
Okay.
K of x is 15.
Oh. Okay, I got it.
And I want to know what x is when that gets me 15.
Oh, okay. All right.
Yes.
To be honest, I'm still really lost on this.
Well, that's because you didn't do your homework.
Still.
You didn't try it last night.
Mr. Lashley, I need some help on the main ring.
You need some help on domain array. We'll talk about that in a minute. Okay, what on this problem?
Everything.
Okay, well then I'm gonna have to help you a little bit later. Okay. Let's go through the guided notes for today. Okay, let's get to the guided notes for today. Just 2 problems in the guided notes for today. Really quite quick and simple. You know how yesterday we talked about function notation, and if you call something a function, you use particular notation. We're going to do the exact same type of thing today, but now we're going to get into graphing these things. Okay? Graphing these functions. Okay. Now, let's kind of recap what this notation means. Like, take a look here at this problem. Because I present this problem to you as f of x is equal to 2x plus 5, now knowing what f of x means, what does that tell you? What is that telling the reader that I present it to you in this way?
That x is half of 2?
No. What am I presenting? From what we know yesterday, what do we if I say that it's that, what do we know? That it's a function. It's not just an equation, that it's a function. If I use the f of x notation, it tells the reader that it's a function. No longer just an equation, it's a function. Do I have to check that it meets the vertical line test? Do I have to check that one input means one output? No. Because it's presented to me in a way that it's f of x is equal to 2x plus 5. That's kind of what we learned yesterday. Question?
So what would make it not a function?
If it didn't pass the vertical line test? If I just gave you 2 as y equals, then we wouldn't know.
Oh.
But because it's f of x equals, yeah, I would watch a video from yesterday.
Yeah.
Okay, now, whenever I give you a table of values, let me ask you this. Are there any limitations on my domain? Are there any limitations on what I can plug in? Like, am I given a word problem where I only can plug in whole number values? No. Am I given a situation where negatives don't make sense? No. So what I'm saying is, I could pick any x value that I want, right? Because, what do I know about my domain? It's continuous. My domain is continuous because I can pick anything that I want, okay? Now, I could pick any negative numbers, I could pick any positive numbers. The only stipulation is, for me, for right now, you've got to pick 5, and they must fit on your graph. Like, if I wanted to be funny and pick 1,000, okay, 2 times 1,000 is 2,000, plus 5 is 2,005. Does that fit on my graph? No. So that's not a valid coordinate, okay? So here's what I suggest, and I strongly suggest, and I say this is what you should do. Use -2, -1, 0, 1, and 2. Okay? Could you pick other things? Sure. But the coordinates that you end up with must fit on the graph, and you have to have 5 of them. More often than not, -2, -1, 0, 1, and 2 are going to be good for you. All right, so let's plug in 2. Or sorry, excuse me, -2. We get 2 times -2. And again, all I'm doing here is finding f of -2. So remember how you guys were kind of complaining about, oh, we got to do 3 of them? Yeah, you're going to have to do 5 of them here, okay? So it's 2 times -2 plus 5. positive 1. And we go back and we do f of negative 1. 2 times negative 1 plus 5. Positive 3. And then it would be 2 times 0 plus 5. But 2 times 0 is 0. And 0 plus 5 is 5. Now, let me ask you something. What pattern do you see in the y values? Goes up by 2. Does that pattern continue?
Yes.
Yeah. So I could say 1, 3, 5, 7, 9. Let's just double check 2 to make sure that it fits. 2 times 2 plus 5. Well, that's, plus 5. Well, that's 9. 2 times 2 is 4, plus 5 is 9. Yeah, that makes sense. Okay, and now we plot our points. Negative 2, comma 1. Negative 1, comma 3. 0, comma 5. Henry. 1, comma 7. 2, comma 9. Now, do I fill in my line? Do I connect my dots?
Yes.
Yes. My domain is continuous. Could I have picked any number? Could I have picked like 1.5? Sure. Could I have picked negative 10? Sure. Could I have picked any point? Yes. Any number would have worked. So you have to fill in the line. Now, here are my rules about the line. Ooh, yeah, I should probably be a little bit more precise. Okay, let's try that one more time. Maybe it might be a good idea to use the line tool. Okay, if you want to use a straight edge, use a straight edge. That's completely fine, but you don't necessarily need to. But here's the deal. It needs to extend not just through the points. I want it to go all throughout the graph. Okay, so if you just made a line connecting your points, okay, extend it. Go through the entire graph that's given to you. Okay? Also, should you put arrows on the end of your graph?
Yes.
Yes. I was just having this discussion with Mr. Gilab right at the beginning of class today. We said, are we going to take off points if we don't put arrows in the end? And we just came to the conclusion, yeah, we are. Because if you don't put arrows on the end of your lines, that means that the pattern will stop. This pattern does not stop. This pattern continues. It's a continuous domain. Okay, let's keep going. Okay, same thing here. F of x is equal to 3 minus x. And again, because I presented to you this way, f of x, you know it's a function. Let's do negative 2, negative 1, 0, 1, and 2. And let's graph our line accordingly. All right, we take 3 minus negative 2, positive 5. We take 3 minus negative 1, positive 4. We take 3 minus 0, well, that's 3. But again, now notice, what's the pattern in my y values? Yep, minus 1. Let's try it. Let's keep going. 2, 1. Let's just plug in 2 just to make sure. 3 minus 2, oh yeah, that's 1. You should always see a pattern like that, especially if you use negative 2, negative 1, 0, 1, 2. So we say negative 2, comma 5, negative 1, comma 4, 0, comma 3, 1, 2, 2, 1. Now again, no dinky lines. Stretch it all throughout the graph. Okay, stretch it all throughout the graph. Pretty good on that one. Put arrows on the end of your line, make it be continuous. Okay? Be careful with that. Make sure you're putting arrows on the end of your line. Make sure you're connecting the dots. It's a continuous domain. Okay, I'm giving you 13 minutes, sorry. Go ahead and start to work on this now. It says show all working answers on a separate sheet of paper. I don't need you to do that on this one. I just did the key this morning and I put it all on this paper. You don't need to do the work on a separate sheet of paper. You can do all the work and answers on this paper. That's fine. I know it says to put all work and answers on a separate sheet of paper. You don't have to listen to that direction. You can just do it on here.